right, we are specifically looking at properties of logarithms today. And one of the main goals we have is to both expand and condense logarithms. So really we are looking at how we can work with logarithms, and it's based on 3 properties that we're going to learn. Prior to learning those 3 properties, I would love for you to take a second and just try these 3 problems on the board. So we've got 3 exponential problems that involve a lot of exponent properties. And if you recall, logarithms and exponentials are inverses. They're connected to one another. So take a second and try these problems because it's going to play into exactly what we're getting ready to do with logarithms. So pause the video, try to simplify each of these, see if you can remember how to combine exponents, and then come back and hopefully I'll jog your memory if you didn't know how to do something. All right, looking at A, looks like we have x's in the numerator and denominator right here. And so we can combine those, if you remember, through subtraction. And so x to the 4th over x squared is the same thing as saying just x squared. In other words, there's 4 x's on top, 2 x's on bottom, so 2 of those will reduce out or cancel out. Then you might also notice that we happen to have y's, y to the 10th over y to the 1st right there. And so again, we can subtract exponents and we would say y to the 9th would be left. All right, if that one didn't work for you, let's try out B. We got y squared to the 5th power, which is really saying we have a repeated y 5 times. And so if you remembered this meant multiplication, you are right. This should have been the equivalent of y to the 10th. 2 times 5 does give us to the 10th power. And then last but not least, we had x cubed and x to the negative 9th. Again, here we can think about what happens when we have exponents with bases being multiplied. Here you can add the exponents. So this would have been equivalent to x to the negative 6th because 3 plus negative 9 is negative 6. And then I hope you remember what negative exponents actually are. They're actually repeated division rather than multiplication, which means that x to the 6th is actually a denominator value. And so we would put our 1 in the numerator to indicate that division by x 6 times. Okay, hopefully those went okay. And if not, hopefully at least jogged your memory that in case C, we were adding exponents. In case B, we multiplied. And in case A, we subtracted. Because these 3 properties of exponents are exactly what we're going to see play out with logarithms. So logarithms also happen to have 3 properties, and you're going to notice they are the product, quotient, and power property. So the purpose of these properties is that we can actually take a logarithm and rewrite it in a different way. Sometimes that means expanding the logarithm, making it larger, and sometimes that means condensing the logarithm, making it go from many logarithms down to one singular logarithm. So if you ever hear expand or condense, you are primarily thinking about these properties. Go ahead, pause the video and write them down, and then come back and we'll talk them through. Okay, so for the product property, as you were writing it down, I hope you noticed that there is definitely multiplication happening here inside the argument of the logarithm. There's an m times n right there. That's the product portion. And you'll notice that the product indicates that we can actually rewrite this logarithm as 2 separate logarithms of those 2 arguments, m and n, but they would be added together. The 2 logarithms would be added together. Notice for a quotient property though, this time we've got division happening, and that division actually transfers over to subtraction. So up here, multiplication transferred to addition, and division became subtraction. And then with the power property, this one might have seemed the weirdest, because really what's happening here is our exponent, that n exponent, is being transferred to the front of the logarithm, but really what's occurring is it's becoming multiplication. So if you look back at our starting problem, this is exactly what we were doing here, right? When they are being multiplied, we add. When they're power to a power, we multiply. And when there's division, we see subtraction. That's exactly what is playing out in these three properties. So if you know one, you're going to know the other one. All right, so one other reminder, I said this, but it might be helpful to also take down note. Expanding means we are taking one logarithm, or at least one log, and we are turning it into many logarithms. Now by many, that could mean 2, it could mean 7, it just depends on the actual problem. And condensed simply means we're going to take many logarithms. That could be 1, that could be 2, it could be 2, it's going to definitely be more than 1, or it could be 10. But we're going to take many logs, and our goal is to condense it down to 1. Now sometimes it can't become 1 and it has to say more than that, but the goal would be to go down to as few as possible. So notice expanding is actually like working the left side of these equations to the right. Okay, so from going left side over to the right side, that is expanding. Whereas working with the right side, so if I started with the right side and I work back, that would be a condensing. So we have many on the right, or even this one is kind of considered an expanded logarithm versus a condensed logarithm on the left. Now right and left doesn't matter on your actual problems, but for these properties, the way they're written, you're seeing the expanded version on the right and the condensed version on the left. Okay, let's try just a couple problems to see if we can make sense of this. So when we look at expanding, we're going to look at 3 separate problems here. You really want to focus in on what operation is happening inside your logarithm. So when I look at problem A, and I notice I have 5 times 6, very overemphasized there, I'm going to immediately think multiplication is happening right there, and I know that is going to translate to addition. So if you look at our properties that we just wrote down, this is actually the first property right here. We have multiplication, we want to transfer it to addition. That means I'm going to be able to take my log base 4 of 5 times 6, and I'm going to be able to rewrite it as 2 logarithms. One log base 4 of 5, and the other log base 4 of 6. And of course, that multiplication then would become addition of those 2 logarithms. And there you go, you've expanded already. The only thing you would want to look at after this is, can I simplify any further? In other words, do I know the value of this logarithm? Do I know what power of 4 is 5? I don't. It's not a nice, easy number. So this is actually a fantastic final answer. We're going to stop right there. Okay, so let's look at B. On B, we've got log base 3 of 4/3, or maybe better read as 4 divided by 3. So since I see division, according to our quotient property, that's going to become subtraction. And so now I know I can just go ahead and write 2 logarithms, log base 3. One of them is going to have 4, the other one's going to get the 3, and they're going to be subtracted from one another. So notice, because there were 2 parts, 4 divided by 3, I end up with 2 logarithms, and they're subtracted from each other. Again, you should check and see if you can simplify this, and one of these is a value we know. So take a second and think about it. Log base 3 of 3. What is the value of log base 3 of 3? 1. 3 to what power is 3? Is of course 1. So this is our best final answer. And don't let your brain trick you. You cannot subtract any further. So 4 minus 1 is not something you can do because it's log base 3 of 4. And then that's it. There's no more. Think of it as there's parentheses stuck right here. Okay, let's try C and see how it goes. Feel free to pause the video and try it if you'd like, or you can just work it right now with me. I'll leave that up to you. All right, on this one, I noticed that there is an exponent. So this is that 3rd property at play. We have that power of 4, and we know that powers are going to translate into multiplication. So that means I can rewrite this as 4 log base 8 of 2, and that would be the fully expanded version. This one is not done because we actually do know the value of a log base 8 of 2. So I'll let you think about that for a second. This is not the easiest logarithm, but I know that you can figure it out if you pause and think this through. How does 8 become 2? Think about powers, roots. It's the cube root. So the 2 cubed is indeed 8. So that means the cube root of 8 is 2. And that means the value of this logarithm is 1/3. The value of that cube root we write as a fraction 1/3. So final answer here is going to be 4 times 1/3, which is just 4/3. All right, now it's time to look at condensing. So expanding, we were taking one logarithm and breaking it out. Now we have lots of logarithms and we're going to try to bring them down to just a single logarithm. So you'll notice for the 3 problems I have here, we have 3 logarithms in the first one. We're going to try to get that down to a single logarithm. The second one only has 2, but again, our goal is to get it down to a single logarithm. So I do have some quick tips for you here. I would strongly suggest working left to right anytime you're condensing. Part of that is just due to the signs that you're seeing, addition and subtraction. Sometimes that makes it a lot easier to condense. But before you do anything else, you should always do exponents first. And exponents don't look like exponents right now, so stop and think about it. There is an exponent in that first problem, in problem A. What is the exponent in problem A? It's that leading 3. Remember, exponents get moved out front to multiplication, so the best thing you can do to start this problem is to actually rewrite the entire problem but with the exponent instead of leaving it out front. Otherwise, our condensing gets a little wild and usually has some errors in it. So move that exponent first. Now, as I am looking at this problem, I can just start working left to right. So you might get really good at this and be able to do all of it in one step. I love it when that happens. But to start, you might just look at 2 logarithms at a time. So I want to look at these front 2. They are being added together currently. So if I think back to my properties, again, this time I'm condensing, so I'm working from this side of the equation back. Addition is supposed to translate back to multiplication. So what that means is I can actually rewrite these 2 logarithms as a single log, and then I'll just take the 2 arguments, the 2 pieces, and multiply them together. So I'll have 4 times 3 cubed. And then of course my minus log of 12 is just in the problem still. I haven't addressed it yet. But now I could do that part. So now that I have 2 logarithms being subtracted, according to the quotient property, that is supposed to become division. So I'm going to have 4 times 3 cubed divided by 12. And that is a sufficient answer. However, we can do that math. We know what 3 cubed is. We know what 4 divided by 12 can reduce down to. And actually, I would probably think of this 12 as 4 times 3. So I could go ahead and reduce my 4's right there. And I know one of those 3's would reduce, which means I really only have 3 squared. I'm fairly certain that this is going to reduce down to log base 10 of 9, or log of 9. I didn't really want to do 4 times 27 there. We could have. It wouldn't have been the worst, but this is also a fast way to get to the solution. So look at that. We went from 3 logarithms down to a single logarithm. Okay, let's try another one. Let's try B. This time we have 2 logarithms, and feel free to pause the video here and see if you can attack it. See if you know what the first step would look like, and then come back and I'll help walk you through it. All right, first thing I'm going to do here is apply that exponent. So I'm going to keep my log base 5 of 4 exactly as it is, but I'm going to take my log base 5 of x, and I'm going to have it as x to the 1/3 power, because I know that 1/3 in the front is really an exponent. And now I'm going to address my addition. That addition is going to become multiplication. Thinking about that property, addition and multiplication are tied together. So I'm going to have 4 and then times x to the 1/3, or in other words, 4x to the 1/3. And there's nothing more for me to simplify here. So this is absolutely an acceptable answer. If you prefer the root version, you could absolutely call it the cube root of x if you would rather. Those are the same thing. All right, definitely time for you to give it a try. So go ahead and try question C here. See how it goes, and then feel free to come back and I will work it with you. All right, again, as I am looking at this one, I see that exponent. So my very first step is going to be to go ahead and rewrite this as the natural log of 5 squared. And then this is a great example of a problem where you might be able to condense it all at once, but some of us might prefer to take 2 steps. So it does not matter in the end as long as you're confident in what's happening along the way. So for example, some of us might just focus on these 2 logarithms at first and then deal with the natural log of 10 at the end. And some of us might be able to say, oh, there is both addition and subtraction, so I know I'm going to multiply and divide. And either one of those methods is all right. You should land at the same answer. I'm going to go ahead and 2-step this just for the sake of showing that work. So addition is going to become multiplication. I will have 8 times 5 squared. And then, of course, that subtraction is going to translate to division. So we'll still have the 8 times 5 squared, but now it will be divided by 10. And so what that means is we could go ahead and calculate 8 times 5 squared divided by 10. Again, I do know that some things are going to reduce. So 10 is 10 times 5. So I could definitely eliminate a 5 with one of those up there. Oh, that's not 10 times 5. I apologize. That's 2 times 5. Really bad math moment there. And then that 2 would reduce out my 8 down to a 4. So it looks like we could call it 4 times 5 in the numerator, which would be the natural log of 20. Lots of ways you could have gotten there, but hopefully you ended up with natural log of 20 in the end. Man, I'm so sorry. My pen is definitely not wanting to highlight the answer for us. And that is the basics of expanding and condensing.